This meeting is being recorded.
For the next problem, 1.7, we will take a look at most of the A through H examples here, but there will be a few for you to try on your own. We're asked to identify any formal charges in the structures below, and if you're not familiar with the periodic table or you don't have it memorized, I would recommend having a periodic table handy to help us with our valence electron count. So let's go back here. So our first structure, we're asked to identify formal charges, and we see that aluminum is a group 3 metal. So we'll go back to our periodic table, and we see that it's in group 3. It should have 3 valence electrons, but when we go back to the structure, we see that it has 4 covalent bonds here, or 4 bonds formed with our hydrogen atoms. So each of those we count as 1 electron. So you can kind of look at the math here. Aluminum should have 3. We'll subtract 4 for that 4 negative charge. So 3 minus 4, we would have a formal charge on our aluminum here of -1. Let's look at B. So in B, we'll look at any formal charges. So all the hydrogens have 1 bond, so they are all neutral. Oxygen, we know should have, right? If we go to our periodic table again, we'll look at oxygen. That's in group 6 over here. Oh, where are we? So group 6. So that will have 6 valence electrons. Let's go back to our structure. And, or it should have 6. So we have oxygen should have 6 minus. So 1 for each of the bonds. 1, 2, 3, 4, 5. We count all the lone pair electrons. So we have 6 minus 5. So we see a +1 oxidation state, or a +1 formal charge on our oxygen. When we go to molecule C here, again, we'll look at our hydrogens. They're all forming 1 single bond, so no negative or positive charge there. Our carbon is neutral. It should have 4 valence electrons if you want to check, right? Oh, let's go back to our periodic table. Confirm carbon's in group 4, 4 valence electrons. So again, if we want to check if it has a charge, we would do 4 minus the 1 electron for each bond. So 4 minus 4 gives us 0. So our carbons and our hydrogens are all neutral. So let's look at our nitrogen. So nitrogen, if you do not recall, we'll double check. That's in group 5 here. So nitrogen has 5 valence electrons, or it should to be neutral. So we'll go back and say 5 minus. So it has 2 lone pairs. So that's 4 right there. And then it has 2 more valence electrons shared in these covalent bonds. So that's 5 minus 6. So we see that the nitrogen has a -1 formal charge. Let's move down to molecule F here, and we'll take a look at this carbon. So I had mentioned that carbon, in order for it to be neutral, would have to form 4 bonds to account for those 4 valence electrons and have that 0 net charge. So what we see here is that carbon has formed only 3 bonds. So we know that 4 minus 3 will give us a +1, a positive charge on this carbon atom here. And what this is actually called is something called a carbocation, which we'll talk about extensively during our review of mechanisms. So let's take a look at our molecule G here, and let's calculate some formal charges. So we'll check. Hydrogens all have 1 bond. They're neutral. This carbon has 4. This carbon has 4 bonds. That's definitely neutral. This oxygen, well, has 3 bonds, 2 lone pairs. What should oxygen have? We haven't looked at that in a while. So oxygen is over here in group 6. So we'll plug in here for our formal charge calculation. 6 valence electrons to be neutral, minus 1, 2, 3 from 1 from each of the bonds, and then another 2, so that's -5. So that gives us a +1 formal charge on this oxygen here. So +1, I'll write that more clearly, +1 on the oxygen. And then our last molecule that we'll look for formal charges is H here. And again, we'll follow the rule with aluminum that we see up there, that it's in group 3. This aluminum has 4 bonds, so we know that that will have that -1 formal charge next to our aluminum. If we check, this chlorine is monovalent, one bond to be neutral, as is this chlorine. But what we see here with this chlorine is that there's 2 bonds and only 2 lone pairs. So chlorine, we'll double check the periodic table again. We see that's in group 7 rather. So this 17 up here, that would have 7 valence electrons for chlorine. We'll come back. Let's subtract. How many valence electrons do we see here? Well, 2 lone pairs gives us 4, and then 5, only 6. So group 7 minus 6 valence electrons. This chlorine would have a +1 formal charge.